Hello everyone and welcome to the 8th experiments from Fundamental Physics Laboratory, Physics Department, Airlangga University in Surabaya, Indonesia. In this experiment, we are going to talk about coefficient of linear expansions. So expansions means change or increase in length, and if the change in length is along one dimension, or for the volumes, then it's called as a linear expansions. The reason behind the expansions is the change in temperature. Thus, it's implied that the change in the temperature will reflect in the rate of expansion. How much material can withstand its original shapes and size under the influence of the heat radiation is well explained using this concept. So if we presume that the effect of pressure is negligible, then the coefficient of the linear expansions is the rate of change of the unit length per unit degree change in temperature. And the aims of the experiments is actually to determine the linear expansion coefficients of three different materials, which are copper, aluminium, and iron, using the linear expansion apparatus of these experiments. The second one is to make a proper comparison between those three materials, and also we need to compare them with the literature, how close your measurements to the literature. In this case, the capacity you're going to have is you are able to describe why this result is far away from the literature or it's pretty much close to the literature. So by doing so, you have a good understanding which ones of the materials is good for the specific purpose of use. So in these experiments, you will use copper, aluminum, and iron as the materials, and you will compare among them. Then you will need to compare your results with the literature, what the literature is saying. The materials and tools we are going to use in these experiments are the following. The first one, I want to say that there are three different cylinder pipes made of different materials, which are iron, copper, and aluminum. The second one, we need stove or burner to build up the water. So you need to build up the water from the environment's temperature or room temperature to boiled. And then you are going to use the hose to make the boiled water flowing through the cylinder pipes of your materials. Okay, so you use hose to flow the boiled water through the pipes. And then the fourth one, we are going to use two different thermometers. The first one you're putting on the top of your boiled water to measure the boiled water temperature. And the second one you're going to use to the very end of the other end points of your pipes. So there are different temperature between these two. You are going to record this. So by taking the average of these two, between these two, you are going to be able to determine the temperature of your pipes in average. Okay, you are not going to be more details into the temperature by the each different positions, because it's not necessary to determine whether the temperature is going to be varying. So it's pretty much enough. You're just taking the average between these two differences, your temperature of your boiled water and your temperature measured on the thermometers on the other ends of your pipes. The last ones, we're going to use the ruler, a very long ruler, about 1 meter or 100 centimeters to measure your pipes, because the pipes is about maybe 80 or 90 centimeters. Okay, so you just need to use this ruler to measure the initial length of the cylinder pipes, because this is going to be expanded due to the heat absorbed by the pipes. So the expansions will not be measured using your ruler. The ruler is just going to be used for the measurements of the initial length before you apply the heat on your pipes. All right? All right, so let's talk about the basic concept we are going to use on this experiment. The basic concepts we are going to use here is about the linear expansion equations. The following written equations are two equations that we are going to use. The first ones we can recall from the fundamental physics, that the difference length between the initial and after our final heating is the following. So L here is the final length of the cylinder pipes after heating, and L0 here is the initial length of the cylinder pipes. Alpha is the linear expansion of your materials. T is the average temperature of the cylinder pipes before and after, and then X here is the expansions coefficient, the difference length. A is the length of the pointing needle. R is the radius of the rotating axis, and T is the number of scale covered before and after the heating. So when we have done the experiments and then we got the data, you are going to use these equations to determine the expansion, the linear expansion equations, the linear expansions coefficients for each different materials. The steps on the experiments are the following. First of all, we need to put the cylinder pipes on the linear expansion apparatus. And secondly, we need to tighten up both screws to make sure that the pipe doesn't move. And then we need to measure the initial length of the cylinder pipe using a ruler. So this needs to be done before the heating. Before you heat it up, then you need to measure the initial length. Then the fourth one is to connect the plastic hose from the boiled water containers to the cylinder pipes, and then record the initial cylinder pipe temperature before the heating, before you flowing the boiled water through the cylinder pipes, and then record both temperatures shown up on the both thermometer after boiled water goes through the pipes. And then we need to read the difference scales between the initial and after to determine the difference length of the pipes after the heating process. So you will get all of the data after you do this step of the experiment. And then the data you need to collect on these experiments are going to be filled up into these tables. So the first row here is your irons or steel materials, the second row here for the aluminum materials, and the third one is for the copper. So L1 and L is actually the initial and the final length you're gonna measure, and then R is the radius of your let's say the radius of your rotating axis. T1, T2, and T2 apostrophe here are the temperature of your initial and after boiling, and then position 1 and 2 is the position for the needle before and after heating. So this is all of the data you are going to calculate to determine the linear coefficients, linear expansion coefficient for different materials. The tasks for the students on these experiments. First of all, the student will determine or calculate the linear expansions equations, linear equations coefficients for the cylinders pipes made of different material, which are iron or steel, aluminum, and copper, using the linear expansion apparatus and linear expansion equations from fundamental physics. Secondly, the student need to compare between their calculations and the reference and evaluate whether their calculation is reasonably close or not by taking into account the error analysis from the error propagation they used. So you're not allowed to just calculate, you need to take into account the error propagation out of from your data. Okay, you need to take into account the error propagation because you measure the measurement, you know the errors, you know the least count, and you know the errors, the final errors for your calculations. So finally, I would say thank you for watching and listening on these dry experiment materials, and keep safe and healthy, and have a nice day.